When I was a kid, we had 9-volt trains. In this system, a regulator controls the speed of train motors by adjusting the voltage sent to the track. This unit contains a stepped potentiometer, and we can clearly see the discrete output on the attached multimeter. The older 12-volt system and many conventional train sets use a similar system. Then came power functions. Being a digital system, PF raises and lowers voltage using a duty cycle rather than an analog switch, but it does more or less the same thing. We still get discrete voltage steps, which we can once again see on the multimeter. Both of these systems don't get any feedback from the output. The motors just run however fast they can. Because of the way torque and power scale with voltage, trains often don't start on the lowest notches, even if they can run very fast at the highest notches. Once they start moving, some setups still can have trouble maintaining a low speed, especially in tight corners, and forget about pulling a heavy load slowly. We can mitigate this a little bit by adding more motors or using more powerful motors, but both of these options take up space, which a small model may not have. Adding gear reduction can also help, but this often reduces the top speed. Well, now we have powered up, and it can do the same thing. In Pybricks, they even call it duty cycle, and it goes from 0 to 100 in steps of 1. One of the weakest motors, the medium linear motor, also called the boost external motor, can't move the SY consistently until the duty cycle goes above halfway, probably corresponding to about 3 to 4 volts. Again, we can mitigate this a little by using a more powerful motor. The very well-named Technic large motor can move the locomotive at a lower duty cycle, though it still slows down in turns. All in all, any similar control scheme driving a similar hardware setup will have a pretty big deadband at lower duty cycles. Now, some of the current motors, including the Technic large motor, have encoders. I talked about this in the Q2 mechanical update. In Pybricks, these motors get an additional run function called run. Using feedback from the encoder, run tries to maintain a speed measured in degrees per second rather than simply output some voltage. This makes a huge difference when trying to move something at a certain speed, and I think people often overlook this particular strength of having a smarter system like Powered Up. Of course, this isn't perfect. The encoded motors are still primarily kids' toys rather than proper precision servo motors. We still get a bit of surging at lower speeds, and this surging gets worse with weaker motors. While it doesn't quite show up that well on video, the medium linear motor surges noticeably more than the Technic large motor. But wait, the duty cycle had a bounded input range of 0 to 100. How do I know how fast a given encoded motor can run? Unfortunately, this doesn't have a clean answer. Philo has documented no-load speeds for most LEGO motors, but these can vary a bit from instance to instance. Furthermore, the practical top speed of a motor in any given system, of course, depends on the actual load. As such, the actual control scheme I have been using on my powered up models ever since the Plymouth CR4 does not use a predefined run range. When I hold the plus or minus, the program tries to increase the target speed until the motor stops accelerating or I release the plus or minus. The light on the controller turns orange when the reported speed goes below the targeted speed. I originally intended to make this an SY mechanical update video similar to the Q2 mechanical update video, comparing different drivetrain options for the SY. But I felt like the DC versus run discussion was more widely applicable. In fact, between now and then, I figured that the Technic large motors synchronized themselves in the Q2 because the powered up app used run instead of DC. I didn't understand this because I didn't understand the icons on the coding blocks without further documentation. Anyway, I want to thank all our subscribers for getting us to 2,000. We will try to do something special for this milestone eventually. But on that note, this is the end of the video. Please consider subscribing if you like what we do, and have a nice day.
Some of the rules in terms of getting like a payment, like if they're using well or something, and I don't really like using some of the